Welcome back to Advanced Programming using C++. Today we're going to talk about local and global variables. Should be a quick lecture. So let's get to it. Okay, so I want to make a comparison on local variables. And we talked about a little bit about scope on the last lecture. If you see here, what I have in main is I've declared a variable called num. This can be classified as a local variable to the function main, meaning that as I go through execution in the function main, num is accessible only within the function main. So if I run this program real quick, and I'll trace through what another function means, you'll see that I wrote out num is 1. Now we step into what I defined as another function. Another function executes, and then I have another variable of the same exact name. Now there is no clash because when you declare a function, when you declare a variable within a function, the variable itself is only local to the function itself. The scope is local to the function itself, which means that num scope in terms of memory space is only within or confined within the function called another function. There's no conflict with main, meaning that they're really in different memory spaces. If you see the output, you'll see that I've declared num, I've assigned it to 20, I've printed it out to output, and you'll see here that on the right hand side, you'll see that in another function num is 20. When the function executes, the existence of the num variable within my function called another function is done. It's kaput. It's disappeared. Meaning that any variables that you declare within a function are gone by the time the function finishes executing. You never have to worry about clashing variable names with doing cross-function clashing. Meaning that if I had another function here that I wrote and I had the same variable, I declared it, it doesn't really matter if I declared another num because the scope of that variable is within that second function. Same concept applies here. Num here does not clash with num here because the scope of num within another function is only scoped within, it only lasts within the another function method or function. Let's not mix, it's not called a method, it's called a function. If you go back to main, once I finish execution of another function, then we can print out, I print out num, which is still the num from main, which is a local variable within main. And there you see that it is printing out 1. Again, when you see the word local variable, that means that the scope of that variable is within the function of where you've declared it. In this case, we've declared num as a local variable of main, and in this case, we've declared num as a local variable of another function. Their scope only lives within the function that they're declared in, and once we finish execution, then that variable goes kaput. There's another concept called a global variable, and you've seen this in my previous lectures, and I went over global constants in my previous lectures for my introduction to programming course. We can declare a global variable outside of main, which means that now I can do the following. I can say int global num, and I won't assign it anything. Now global num is now a global variable, meaning the scope is within every function. It's accessible within every function, including main. Now, what would happen if I did the following? If I declared a local variable called global num, and I also have a global variable called global num. This is a concept called shadowing. What that means is that the local variable will shadow the global. So what value does it take when you shadow it? Well, when you shadow it, it's actually going to take the value of the local variable, meaning that if I declare this as 20, I'm going to get rid of this hello world here. Again, this is a new concept called shadowing. So if the shadows the global, just going to say global num. So if I print that out, it's going to print out the value of 20 because, again, this is what we call shadowing in C++. It's the function itself is going to take the local variable declaration over the constant, not the constant, the global variable. So this is a global variable. Best to avoid this, obviously, right? Best to avoid declaring global variables at all. But you may see some programs lying around where they do have some global variables declared. I know I've been guilty of that when I taught you Introduction to Programming 1, but I did it because our lessons were focused on just being inside the main. There are times where you will have to declare some global variables, and I'm not saying it's something that you should never, ever do, but it's best to analyze a use case of why you would want to declare a global variable in your program. Again, I want to emphasize that global num is hidden. That's what we call shadows. So this will shadow the outside global variable. Again, you should really never do this, but it's something that I have to make you aware of so that if you see this, you don't get confused as to, well, who gets what. So the technical concept or technical term is called shadowing. And what's happening is the local variable shadows the global, hence you get the local variables declaration and instance in the main function. Now remember I said on a case-by-case basis you should avoid global variables, but it's mostly accepted that you can declare a global constant. And what I can do here is I can say global constants. I can say const double, we'll just say pay rate equals 20.00. Constants are generally okay because these are things that perhaps will not change, and if it does need to change, it's something that's accessible throughout your program and it's not going to change as much. This is one use case where you would use a global constant. So I just want you to make sure I'm categorizing the difference, right? This is a global variable, meaning that this can be reassigned anywhere in your program, which is not good practice. But this is a global constant. Because it's a constant, it cannot be reassigned anywhere in your program. It's accessible. So we can think of this as read-only, right? This is a read-only variable. And this global variable is a read-write, right? You generally don't want any globals to be writable. So that's why it's accepted that you can use globals as long as they're a constant. And if they are a constant, then you really are only reading from them. And your functions themselves can access this global constant. The same shadow rules apply so that if you do declare another constant within your function or any function, it's going to shadow the global constant variable. So the same rules apply in terms of shadowing. Okay, so those are kind of general accepted rules, at least in my opinion. And I think mostly widely accepted, I would say. So you're probably asking, well, why is it bad practice to declare a global variable? Well, because you can read and write to it anywhere in the program. So it's going to become very hard to try and debug and find any errors in your program if there aren't any. If there's a global variable that can be rewritten and reassigned, then it becomes a very, very difficult situation where you would have to go and dig in as to where this global variable is referenced in which functions and what function is changing and which function is not. That's why we generally want to stay away from global variables because, again, because it could be reassigned, rewritten, a lot of functions can touch it and you don't know which ones are going to be able to read and write to it and then to track down bugs. If you have a constant, really nobody can reassign it. And if you needed to reassign it, you do have to do it at the top level of before the main, right? So if I change the pay rate, I could just change it to maybe 10 or 25, and that's fine. But that nobody else is going to be reassigning this constant because once you assign it a value, it can't be reassigned again. Now, what I want to do is I want to give you a visual representation, as I always do, of what's actually happening here. So if I have my main, this num is visible only in main. Only in main. And we covered that in the code, right? Whatever I have num referenced in main, I've declared it, so it's only visible in main. We have another function which we've defined, right? And this is visible only in another function. Now again, another function is my function name, right? That's the name of my function. Don't think that I'm just saying another function. Which means that the scope of this num is only within another function. And the scope of this num is only within the main, right? And when we start execution of another function, once it ends, the num of another function is kaput, it dies. It pops, what we say, it pops off the stack. And when we give control back to the main, then again, because this num is only visible to main, then we can manipulate that. But there will never be any cross. This is no good. There will never be any type of cross contamination of variables if we declare them local. Now, if we had a global variable, then that's when problems are going to start, because if I had a global, let's say num, right, then this function here and this function here can actually write to my global variable. So again, that's no good, right? That's no good. But if I have a global constant, I can only read from it, and it's visible again in all functions, right? Global constants are visible in all functions. So a couple of summary points is trying not to use local variables and main function variables. Try not to rename them the same. So if you're looking at your code, try and change the name around a bit because it makes it less confusing, right? I mean, I know you're learning the concepts now, but it'll make it less confusing in the future. Don't use global variables. It's not good practice. If you do have to use a global variable, make sure it is a constant, because the constant will only be readable by all functions. So that's another step. And if you do decide to mix a global variable or global constant and declare the same variable with the same name, not the same variable, because the function will have its own instance, the concept of shadowing comes into play, where the local variable supersedes the global. So the local variable will shadow the global, and it's going to use the local variable instead of the global. So just a couple of things that I wanted to run by you, and I hope that you've differentiated between local and global. I'll see you on the next video. We'll talk about static variables.